P6 Prelim for Tong 2025 paper 2. Question 1. The table shows the water charges. So Mr. Chan paid $89 for using 60 cubic meters of water. How much did he pay per cubic meter for water consumption more than 40 cubic meters? So in other words, we're trying to find this question mark. Okay, how we read this table is firstly, the volume of water is being divided into two parts. The first part is the first 40 cubic meters. And then anything more than 40 will be charged at a different rate, okay, which is the rate that we're trying to find. So for the first 40 cubic meters, it is $1.40 for every cubic meter. So how much would that be? So part of his 89 will be for the first 40 cubic meters, which is 40 times $1.40. That will give us $56. So out of the 89, part of it is 56. So the rest of it would be 33. Okay, so 89 minus 56, 33. So $33 is the amount that he has to pay for the remaining volume. The total volume that he used is 60. So I know that if this is 40, right, then the remaining will be 30. So 60 cubic meters minus the first 40 cubic meters would give us 20 cubic meters. So if 20 cubic meters is at $33, he paid $33 for that, then 1 cubic meters would be 33 divided by 20. Okay, which is $1.65. So every 1 cubic meter is $1.65. There's also what it means when I say per cubic meters. Okay, for every 1 cubic meter. Question 2. Dina had 2.07 kg of flour. First, she used 459 grams of it. How many kilograms of flour was left? Okay, this requires you to do conversion between kg and grams. So let's convert to grams first. It's easier to see. If you want, you can convert 459 to kg, but then you'll be using decimals. You have to work with decimals lah. Okay, so to prevent careless mistakes, I'm going to change it to grams. So 2 kg is 2,000. So times 1,000, 2070 grams. Okay, so to find what's left, I'll take total minus 459 grams, which is 1611 grams. To convert it to kg, divide by 1,000, so 1.611 kg. Okay, so 1.611. Question 3. Line graph shows the growth of a plant over 4 weeks. So starting with week 0, and then you have week 1, 2, 3, 4. Okay, what's the percentage increase in the height of plant from 1 to 3? So at week, okay, let's put in all the numbers first. Week 0 is a 10. So 0 to 10, count the intervals. There are actually 5 intervals. So every interval represents a 2. Okay, every time you go up by a line, it's 2 cm. So week 1 would be 14, week 2, 42, week 3, 56, and then week 4, 62. You want to find percentage increase from week 1 to week 3. This is 14 to 56. Increase over original times 100%. So your increase is 56 minus 14. Okay, which is 42. 42 over original, over 14. Don't put it over 56. Okay, it's always the increase over the original number. Then times 100%. This will give us 300%. Question 4. Triangle ABC is an isosceles triangle that lies within a figure made up of a semicircle and a rectangle. AB equals to AC. Okay, let's mark that out. And then you're supposed to find the area of this triangle. So area of triangle is half times base times height. The base is 15, the height is here. So to find the height, this one, it's made up of two things. One is the radius of the semicircle, and then this is 9 meters. So how to find the radius of the semicircle? To find the radius, 15 would be the diameter. So radius is 15 divided by 2. So if this is 7.5, then this is also the radius. This is 7.5. So the height of triangle would be 7.5 plus 9, 16.5. Area of triangle ABC, half times base times height. So half times 15 times 16.5. Okay, so answer 123.75. Okay, next question, question 5. Figure is formed using two squares and two equilateral triangles. Perimeter of the figure is 120 cm. PQ is a straight line. What's the length of PQ? If you have a square, means this. Okay, let's just look at the perimeter since we're given perimeter. So these three sides will be the same, right? Now, this is also equal, which means that if this is equilateral, then this two will be the same as well. Okay, so in this, you have like 5 of the equal sides. Same for this one. Square, then equilateral. Okay, so if I were to name this and this like A, B. Okay, then perimeter is made up of how many A? 1, 2, 3, 4, 5, 5A and 5B. That will give us the 120 cm. From P to Q is made up of A plus B, 1A, 1B. So if I want 1A plus 1B, I'll take 120 divided by 5. Take note, divide by 5, not divide by 10. Because if I want to get 1A, 1B from this, I divide the whole thing by 5. Okay, so answer 24 cm. Question 6. A group of students were asked to choose their favorite fruit in a survey conducted. Result shown in this pie chart. Okay, some of the results given in fraction, some in percentage. Half of the number of students chose either mango or orange. So this is half, or 50%. Okay, what fraction chose apple as a favorite fruit? Now, I know that this is 50% Then this would be 50% as well. So for the apple will be 50% minus 35%. So this is 15%. Okay, why do I choose to use percentage instead of fraction? If I were to change to fraction, right, I'll be working with different denominators. It's very hard to compare. But if I use percentage, then everything will be out of 100. Okay, so okay, before I do part A, let's find out all the percentages first. So for mango, one fifth as a percentage is 20%. If mango and orange is 50%, then orange will be 30%. Okay, so for part A, what fraction chose apple as a favorite fruit? Then I'll just convert this percentage into fractions, which is 15 over 100. Simplify, divide by 5. So 3 over 20. Then using what we have, let's answer part B. More chose orange than pear as their favorite fruit. So you just compare the percentages, orange versus pear. No, not true. Pear is more. So false. And 20 students chose mango as their favorite fruit. Here we have 20%. 20% may or may not represent 20. Okay, we cannot tell because there's no information on the actual number of students. So it's possible, but maybe other numbers as well, so not possible to tell. Next, more students were surveyed and all of them chose mango as their favorite fruit. Percentage of students who chose apple as their favorite fruit remain the same. The number of students who chose apple will remain the same, but the percentage of those that chose apple will not be the same because you see, percentage of those who chose apple will be apple over total times 100%. Right. So the apples, if the apples number of students who chose apple doesn't change, but your total change, right? Because they said more students were surveyed. If your total goes up, then the value of this fraction will actually decrease. Right? If your denominator increases, then the value of the fraction actually decreases. It becomes smaller. So the percentage of students who chose apple will actually decrease. So that is false. It will decrease, not remain the same. 7. So you have an empty container here. Base area 30 square cm. Now the container was filled with some water and you have like the front view of the containers. This when it's standing upright, and then this one when it's upside down. The amount of water is still the same. It's the same container. Okay, so what's the capacity of the container? So firstly, the container includes the water, volume of water, and the volume of air. Okay, volume of water would be base area times height. I mean, from figure 2 is easy to find volume of water. From figure 3 is easy to find volume of air. So what we need to do is just add them up and you get the capacity of the container. So base area times height. Water, volume of water, You take base area, which is 30, then times the height. Which is 138. Okay, then next, you want to find the volume of the air, right? The whole thing is 7.8 cm. When it's inverted, the water comes to a height of 5.5. So the air would have a height of 7.8 minus 5.5. Okay, which is 2.3. Then volume of air, base area times height, which is 69. Now, capacity of container, you just add them up. So water plus air equals to 207. So answer 27 cubic cm. Hey, JK, this is question 8. Where's J? JKLM is a rhombus. Then you have K, it's K. K, KLN and KLO, they are triangles. LM equals to MN. Let's mark up equal sides. And because it's a rhombus, so you have 4 equal sides here as well. Okay, then pi LOK. LOK, this angle over here. Now, this angle over here, you have parallel lines, right? Cos rhombus. So you actually have an alternate angle, which is like the Z, like that. So angle LOK here is actually 21 degrees, same as angle L at MLO. Next one, LNM. LNM, which is here. Okay, so firstly, this is a rhombus. Okay. How I want to find this is using this isosceles triangle. Then I will minus this angle divided by 2. Okay, so I will try to find this angle here. And to find this angle here, I will need NML. No, sorry, not MML. Okay, wait. This is 72 degrees. 72. So this is a rhombus. So this is isosceles triangle. So I'll find this angle so that I can find this angle. Let me remove this first. So I will use this triangle here. Okay. And I'll find so the highlighted triangle is isosceles triangle with these two base angles being equal. So 180 minus 72, and then you divide by 2, you can find LMK here. angle LMK, 180 minus 72, divide by 2, that will give us 54 degrees. So this is 54. Then next, find this NML, okay, in the next isosceles triangle. NML. So on the straight line, 180 minus 54. 126. So this over here is 126. So since we have an isosceles triangle, 180 minus 126, then you divide by 2, okay, to get the angle that we want. So LNM, 180 minus 126 divide by 2, which is 27 degrees. So answer 27 degrees for this LNM. Question 9. Okay, Kai read part of a book in the morning. The ratio of the number of pages he read to the number of pages that were unread was 6 to 5. After reading another 195 pages of the book in the afternoon, Kai still had 10% of the book unread. So how many pages were there in the book? Okay, so at first, the ratio of pages read to unread would be 6 to 5. Okay, okay, let's use fractions. Your total is always the same. Okay, so in the morning, let's do fraction in terms of what's read. So you have 6 out of 11. What's your total units is 11. Then in the afternoon, you have 10% unread. So afternoon left, unread. After afternoon. Which means like in the end, you have 10% unread. So 10% is 10 over 100, which is 1 out of 10. Okay, this is read. Read in the morning. So your total is 1 whole. You minus away what is being read in the morning. You minus away what is left unread. You would get the fraction that is read in the afternoon. Okay, so read in the read afternoon. In the afternoon. So 1 whole minus morning minus left. Then you end up with the fraction that is read in the afternoon. And from here, 39 over 100 of the book is the 195 pages that he read in the afternoon. Sorry, not over 100, over 110. Then 1 over 110 of the book would be 195 divided by 39 equals 5. Okay, so the whole book would be, so that's one whole, 5 times 110. So answer 550. Question 10 is on speed, so let's skip this question. Okay, question 11. A fruit seller had some mangoes. He sold 2/5 of them and donated 104 of them. He was left with 1/5 of the mangoes and packed them into 24 bags. Some contained 4, some contained 6. So how many mangoes were packed? Okay, so firstly, one whole, he sold 2/5 of them. Okay, and donated 104 of them. Then what's left is 1/3 of them. Now take note, this 1/3 is not 1/3 of the remainder. Okay, it's 1/3 of the mangoes, which means the original number. So 2/5 is out of the total. 1/3 is also out of the total. So you can find the common denominator for both. Okay, so is 2/5. Left is 1/3. So same denominator. This is 6 over 15. This is 5 over 15. So if he sold 6 units, left 5 units, right? How many units are donated? So donated will be 1 whole minus 6 over 15 minus 5 over 15, which is 4 over 15. So 4/15 of the total is 104. Then we find 1 over 15 of the total. So 104 divided by 4, which is 26. How many mangoes were packed? Okay, the amount packed is the amount left. Because all the mangoes that were left were packed. So we're looking at 5 over 15. So 26 times 5. Okay, so 130 mangoes were packed. B, how many bags contain 6 mangoes? Now this is supposition. So there's a total of 130 mangoes and 24 bags. But we don't know how many contain 4, how many contain 6. So since we're looking for 6, we start off with the opposite. So suppose all contain 4. 4 mangoes. Okay, so the total number of mangoes, there are 24 bags, right? So 24 times 4. So 96 mangoes. Not enough. We need 130 mangoes. So not all of them are bags of 4. So the extra that we want to make it to 130 would be 130 minus 96. We need another 34 more mangoes. So since not all of them contain 4, we're going to exchange them. So every exchange from a packet of 4, from a bag of 4 to a bag of 6, I get extra 2. Okay, I get extra 2. But I need extra of 34. So the number of exchanges I need to do, okay, number of exchanges to get 34 would be 34 divided by 2. So 17 times. 17 times I'm changing bags of 4 to bags of 6. So how many bags of 6 do I have? The answer 17. Okay, I'm doing it 17 times, so I'm putting in 17 bags of 6. So answer 17. Question, this is 12. Question 12, you have a figure here made up of 4 identical quarter circles. So quarter circles will be in each corner. Then 2 identical squares of sides 14 cm. The square is in the middle here and here. Then the rectangle here. 4 identical semicircles lie within the figure. Okay, the unshaded parts. The unshaded semicircles. Find the perimeter of the unshaded part. So the unshaded part is made up of 1, 2, 3, 4 arcs of a semicircle plus 19, 19. Okay, so to find the arc of a semicircle, you need diameter. Diameter, firstly, let's mark out all the equal sides. You have squares, right? So this side and this side equal. Since you have quadrant means the radius will be equal. So this side is equal to this side. Same for this. So actually the two diameters will be 14 times 2. Sorry, 14 times 3. 14, 14, 14. 14 times 3, 42. So the diameter of semicircle, 42 is 2 diameters. So 42 divided by 2, which is 21. Then we find 1, 2, 3, 4. 4 arcs of 4 semicircle arcs give you 2 circles. The circumference of 2 circles. So circumference is circumference of 2 circles using diameter would be pi or 2 times pi, which is 3.14 times diameter. This will give us 131.88. This. Okay, then we're just missing the 19 and the 19. So 131.88 plus 19 times 2. So 169.88 cm. Okay, that's the perimeter. For part B, area of the shaded parts. So shaded parts, I'll take quadrants, 4 quadrants, 2 squares, and then minus 4 semicircles. Okay, I'm just gonna ignore this part in the middle. Just take the top, take the bottom. So quadrant, square, quadrant, quadrant, square, quadrant, then minus the 4 semicircles. Okay, so quadrant radius is 14. So let's find area of a quadrant first. The quadrant is 1/4, so 1/4 times pi, 3.14. Radius is 14. This is 153.86. Okay, then actually we can also find the whole circle straight away, right? Then after that you minus the, no, sorry, then you add the 2 squares. Okay, never mind. Let's add the 2 squares first. 14 times 14, area of square. 14 times 14 equals to 196. Okay. We find the top first, then after that we times 2. Here the top is 2 quadrants and 1 square. 2 quadrants plus 1 square. Then you minus 2 semicircles. Okay, so 2 quadrants. 2 times 153.86. Then plus a square. Oops. Plus the square. This will give us 503.72. Then minus the semicircle. Okay, let's use another color. So area of semicircle will be half times pi times semicircle. Semicircle, the radius would be 10.5. Okay, sorry, radius is 21 divided by 2 equals 10.5. So I'll use 10.5 for the radius. Okay, then this will give me 173.0925. So I'll take I'll take two, okay, let's look at the bottom one. 2 quadrants plus a square, which is your 503.72, minus 2 times of your semicircle. So 503.72 minus 2 times of 173.0925, which is 157.535. Okay, so that is one part of the shaded. Then you have 2, so times 2. Okay, so last step. 157.535 times 2. Get 315.07. That is the whole of your shaded part. Squares here. Question 13. Okay, we have two rectangular tanks A and B. A was 1/3 filled at first and B is empty. What's the volume of water in A at first? Okay, so just take 1/3 times length times breadth times height. 11,520 units will be cubic cm. For part B, both taps were then turned on at the same time. Water from both taps flowed at a rate of 2.4 liters per minute. How long did it take for the height of water in both tanks to be the same? Okay, so A already had some water, and how long will it take for both of the water levels to be the same? Okay, so let's find out in 1 minute what's the water level A will increase by, and then in 1 minute how much will the water level in B increase by. Okay, we have 2.4 liters, which is 2,400 cubic cm. So we take that, divide by the base area, and then take the volume, divide by base area, you find the height increase. So the increase in water level in 1 minute. Okay, for A, 2.4 liters per minute, so 2,400 cubic cm for every minute, right? A divide by the base, so divide by 48, divide by 20. So every minute, the increase in water level is 2.5 cm. For B, so same volume, but divide by the base, so 60 and 10, which is 4. So B will increase faster. I mean, the water level will increase faster than the water level in A. So eventually, the water level in B will catch up with A. Okay, although A started first, it's like there's already some height, right, in the water level. Okay, so how much will B catch up by in every minute? So we find the difference in 1 minute. B is 4, A is 2.5. So B will actually catch up by 1.5 cm. Now, this original height here is 1/3 of 36. Okay, so 36 divided by 3, which is 12 cm. So A already started with 12 cm of water level. Now for B, right, every minute it catches up by 1.5 cm. So it needs to catch up by 12 cm. So how long will it take? So you take 12 cm and divide by every minute is 1.5. So this will be 8. Okay, so 8 is in minutes, 8 minutes. It will take 8 minutes for it to be the same level. Question 14. Okay, for this type of diagram, right? Usually there are a lot of equal lines. Okay, read the question carefully, don't miss out any information. So here you have a square, A, B, C, you have a square. So mark out all the equal lines first. So students usually can't do this question because they don't label the equal lines and they miss out on a lot of isosceles triangles. Okay, then ABE is equilateral, so you have more equal lines. And DECF is trapezium. So the only thing about trapezium you need to know is that there's one pair of parallel lines. So label them. Okay, so DE parallel to FC. And FGA, this is a straight line. So find angle DEC. Okay, this angle marked out over here. So firstly, this is, no angles are given in this question, but if it's equilateral, I'll know that this is 60, 60, 60. So what I can find, okay, I'm going to use like different colors so that it's easier to see. Okay, let's find this one first. DAE. So since square got right angle, so 90 minus 60. So this is 30 degrees. Now, I'm going to find this angle over here. This angle here would be, this is isosceles. So 180 minus 30 and then divide by 2. So here, DEA, AED, DEA. 180 minus 30 divide by 2, which is 75. So this is 75. Okay. Then the bottom one, right, if you notice, it's actually the same thing. This is 30, and then you have isosceles. So this is also 75. Okay, then now I can find DEC. So using 360 minus 60, 75, 75, which is 150 degrees. Then for part B, find DFC. Okay, this angle here. So I have this is square, so this is right angle, which means that FDC is also right angle. Wait. Oh, okay. This is right angle, 90 degrees. Using parallel line term, this one. Then you have a line cutting through. This means that this angle here is the same as this one. Okay, and that is 75. So ADE is 75. So DFC is also 75. Okay, since it's a 2 mark, okay, then we should just write down. If you just write the answer, it looks like, look, okay, ADE, because this is 75, we already found, right? Isosceles triangle, so ADE is also 75. Okay, so ADE, wait, ADE is the same as DEA, which is 75. DEA is this one. Then ADE, then DFC equals to ADE, which is 75 as well. DFC, ADE, these two are equal. So this is 75. Okay, if you can't see this corresponding angles, right, what you can do is use 180 minus 75, and then you find this angle FDE. Then using interior angles, 180 minus FDE will get you this DFC also. Okay, so that's another way to look at it. Question 15. Shall we use rods to form figures that follow a pattern? First four figures are shown. Okay, got figure 1, 2, 3, 4, number of rods used. What is the difference between the number of rods used for 7 and 9? Okay, let's try and find what's the pattern here first. So for pattern 1, you have 7 and then it becomes 10. You're adding 3. Then after that, you add 2. Okay, so you add this 1, 2, 3 first, right? Then after that, you add 2. Then next one, you add 1, 2, 3 again. Then after that, the next one would be add 2 for the next figure, figure 5. So it always follows a pattern plus 3 plus 2 plus 3 plus 2. Figure 7 to 9, right? You jump by 2 figures. So you see figure 1 to 3, you add 3, add 2. Okay. Then for figure 2 and 4, you will add 2, add 3. So no matter what is, if you're jumping by 2 figures, right, what are you adding? You are adding 2 and then 3, or 3 and then 2. So you're just adding 5. The difference between any 2 figures is always 5. It's always like 3 and 2. Okay, so maybe I use highlighter. Example 1 to 3, jump by 2, right? So you add 3, then add 2. You add 5. The difference is 5. That's for part A. Okay, how many rods would she use for figure 99? Now, figure 99. Hold on, let me remove this. Okay. Okay, so figure 99, we use interval concept. So basically, how are you going to get figure 99, right? So what we do is we start off with a 7, then we add 3, add 2, add 3, add 2, add 3, add 2, and so on. So 3 and 2, the 3 and 2 and 3 and 2, they are called intervals. Okay, but because the intervals are not all the same number, we will group them. So I will group these two in a group. So this is one group of 2 intervals. So for figure 99, how many intervals are there? So the number of intervals would be 99 minus 1, which is 98. Now, if there are 98 intervals and I group every 2 intervals together, right, the number of groups, so you got 98 intervals, then you group them into groups of 2. So 98 divided by 2, you get 49. 49 groups of this, 49 groups of 5. So 49 groups would be 49 times 5. 2, 4, 5. Okay, so all of this plus 3 plus 2 plus 3 plus 2 sums up, they will sum up to get 2, 4, 5. The only thing missing now is this 7 to get the total number of rods. So we take 2, 4, 5 plus 7. Okay, you need to add the number of rods for the first figure. Then you get the total number of figures, which is 252. Question 16. 3 girls, Mabel, Candy, and Lillian had the same number of coins. Mabel had only 20-cent coins. Candy and Lillian each had a mix of 20-cent and $1 coins. Candy had 36 $1 coins. Lillian 13 $1 coins. So of the three girls, who had the least and who had the most? Okay, let's just record down what the question said. Mabel, only 20-cent coins. Then Candy and Lillian. Okay, Candy, Lillian has they have 20 cents and $1 coins. Candy is 31 $1 coins. Okay, so don't know how many 20-cent coins. Okay, plus 36 $1 coins. Lillian, don't know how many 20-cent coins, plus 13 $1 coins. Now, same number of coins for each of them. So the person who had the most amount of money would have the highest value of the coins, right? So if you compare what they have, Mabel definitely has the least because she only got 20-cent coins, like the lowest denomination of coins. Between, oh, okay, so least is Mandy, sorry, not Mandy, Mabel. Then between Candy and Lillian, you compare the $1 coins, the person who has more will have more money. So Candy has the most. For part B, Candy used half of her $1 coins, okay, can find, and some of her 20-cent coins to buy a book that cost 20.40. So how many 20-cent coins did she use? Half of her $1 coins, she has 36 $1 coins, so half of that. 36 divided by 2, 18. 18 $1 coins would basically be $18. But the book cost 20.40. So 20.40 minus all that $1 coins, you get 240. 240 is made up of all her 20-cent coins. So how many 20-cent coins is that? So 240 divided by 20 cents, that'd be 12. Okay, she has 12 20-cent coins. C, what is the difference in the total value of Mabel and Lillian's coins? Okay, Mabel only 20-cent coins. Lillian got some 20-cent coins and 13 $1 coins. I'm going to use a model to show you. So Mabel and Lillian, the number of coins is the same. Right? They have same number. The model represents the quantity of coins. Mabel only has 20-cent coins. Then for Lillian, okay, I don't know how big, I don't know what's the split like, but I know that she has some 20-cent coins and also $1 coins. 13 of them, 13 $1 coins. Okay, that's right here. In terms of quantity, this is 13. Now, if you compare Mabel and Lillian, right, the difference actually comes from this part here. Okay, hold on. Yeah, highlight. 20-cent coins versus $1 coins. So the difference actually comes from this part here, right? 20 cents, no difference, but 20 cents versus $1, there will be a difference in terms of value. And 13 means 13 20-cent coins versus 13 $1 coin. So between $1 and 20 cents, the difference is 80 cents. And we're talking about 13 of each. So this difference times 13. So 1040. Okay, so answer 1040. Alternatively, you could also find the 13 $1 coins and 13 20-cent coins. Then you minus and you get the answer as well. Question 17. Okay, there were 16 more students in Team A than in B in a competition. 1/4 of the students in A and 3/7 of the students in B were girls. Number of boys was twice the number of girls in the competition. How many boys were there altogether? Okay, this question is quite challenging, but I'm going to use model to show you how you can do this question. So firstly, there were 16 more in A than B. Okay, so A, let's draw this long. The difference is 16. Okay, then we want to take 1/4 of A. So 1/4 of A out. Okay, not remove, but they represent the girls, right? Okay, so let's take from the front. Our shade, yeah, I use another color. No, actually, never mind. Okay, so this one is for girls. I use highlights. Oops. 1/4 for girls, right? I also need to remove 1/4 of 16. 1/4 times 16 equals 4. So this is 4. Then 16 minus 4 equals 12. So this is 12. This is for girls. Okay, so I've already differentiated the girls from team A, which means that the rest of them will be boys. Okay, because you can't highlight in your working, right? You might want to use like shading for maybe the girls. For B, 3/7 of them are girls, so cut into 7 units. Okay, so 3/7. Okay, maybe I write team lah, in case you get confused over the B, team B and boys. Okay, it's for girls, boys. Okay, now the number of boys was twice the number of girls in the competition. How many boys were there altogether? Okay, before I continue, right, you have this 4 units which is the same as 7 units for team B. 4 units of A equals to 7 units of team B. So change to the same number of units. So this will be 7 each. This will be 4 each. So you get 28 units. Common multiple. So now you have units. You don't need to use like units and parts. So boys twice of girls. Okay, boys how many units? How much in total based on the model? And then girls how much in total based on the model? Okay, so total girls would be 7U plus 4 from team A and then 12U from team B. So total 19U plus 4. Then the total number of boys would be all those in blue, 21U plus 12 plus 16U from team B, 37U plus 12. Okay, now the boys was twice of the girls. So if I were to take the girls and I times 2, right, I should get the same value as the boys. So 2 times of the girls will give me the boys. So 2 times of the girls would be 38U plus 8. Okay, I'm using this and then I times 2, which is the 37U plus 12. Then both sides, minus 8, minus 8. So 38 units equals to 37 units plus 4, which means that the 4 is 1 unit. Okay, so 1 unit is 4. How many boys were there altogether? Okay, total boys is this one, 37 units plus 12. So we find 37 times 4, then add 12. Okay, so total boys 160. Okay, that's all. That's all for Tong paper 2, 2025 prelim exam.